In this problem, it is given that the sum of the number of factors of n and that of n square is 34. If n is less than 150, how many values can n have? So, first thing that we need to understand here how we compute the number of factors of a given number. If n is any number of the form a raised to power p into b raised to power q into c raised to power r and so on, where a, b, c are prime factors of the number and p, q, r are indices of a, b and c respectively. So from here it is obvious that p, q and r have to be natural numbers. So if the number is of this form, then number of factors of n is given by p plus 1 into q plus 1 into r plus 1 and so on. And we know that if n is a perfect square, then here power of n or power of prime factors of n have to be even numbers, and if p, q and r are even numbers, then from this formally we can observe that this quantity will be an odd quantity, this will also be an odd quantity, and the same will go for this one. So the product of two or more odd quantities is always an odd numbers. From here we can conclude that a natural number which is a perfect square or a square of another natural number will always have an odd number of factors, and from here it can be noted that as sum of the number of factors of n and that of n square is 34, which is an even number, and we know that n square has odd number of factors, that is sum of some odd quantity and one more quantity is 34. From here it can be concluded that the number of factors of n will also be an odd number. From here it can be inferred that n is also a natural number, that is the perfect square of another natural number. From here n has to be a perfect square. Now the next thing that we need to observe whether n the number of factors of n square will always be more than the number of factors of n or not. Yes, it will, in that n is not equal to 1. Now the next thing that we need to observe is the number of different prime factors that n can have. N can have no prime factor, as is the case with 1, but in that case the sum of factors of n and that of n square would not be equal to 34. So n will have at least one prime factor. From here it can be reduced. When n has exactly one prime factor, then n will be of the form a raised to power p. In that case the number of factors of n will be p plus 1 and that of n square, which would be a raised to power 2p 2p plus 1. This has to be 34. And one more thing can also be noted, that the highest value that this quantity can assume for a number which is less than 150 is for 2 raised to power 7, which is 7 plus 1 into 14 plus 1. This has to be sum, not into. It is 8 and it is 15, and this is not equal to 34. From here it can be stated that the value of this quantity will never be equal to 34, given that n is less than 150. So this is not possible. From here it is obvious that the number of prime factors of n has to be more than 1. So now let's consider case of two prime factors. In that case, n will be of the form a raised to power p into b raised to power q. As we know that n is a perfect square, so p as well as q will be even natural numbers, and the smallest value that they can assume is 2. So let's check whether the given condition holds for p and q both being equal to 2 or not. A raised to power 2 into b raised to power 2. In this case, the number of factors of n will be 3 into 3, and that of n square will be 4 plus 1 into 4 plus 1, which comes out to be 34. From here it is obvious that number of this form will have the number of factor for n and the sum plus the number of factors of n square as 34. So let's check how many different values of n are possible when it is of the form a raised to power 2 into b raised to power 2, such that it is less than 150. So first is number that will be of this form 2 raised to power 2 into 3 raised to power 2. Second number 2 raised to power 2 into 5 raised to power 2. Now next number that would come in this sequence could be either 2 raised to power 2 into 7 raised to power 2 or 3 raised to power 2 into 5 raised to power 2. It can be noted that both of these numbers are greater than 150, so these numbers are not possible. The number of values that n can assume when it is of this form, that is a raised to power 2 into b raised to power 2, is 2. Now let's check for other possible values of p and q, whether n has some value or not. Next possible case would be of a raised to power 2 into b raised to power 4 or vice versa. In that case, let's check what is the sum of the number of factors of n and that of n square. In this case, the number of factors of n is 2 plus 1 into 4 plus 1 plus the number of factors of n square, which will be 4 plus 1 into 8 plus 1, which is equal to 3 into 5 15 plus 4 into 5 into 9 45, which is obviously not equal to 34. Hence this case is not possible, and in all the other possible cases the value of the value of the sum of the number of factors of n and that of n square will always be more than 34. So there is only one possible case when n is of the form a raised to power 2 into b raised to power 2, the sum of the number of factors of n and that of n square will be equal to 34, and in that case n can assume two values, and these values are 36 and 100. Hence option D is our answer in this case.